All right, today's lesson is mainly, this is 14.1, sorry. This is mainly vocabulary based today. So quadratic function is a function that can be written in the form of y equals ax squared plus bx plus c. Now this is familiar because we've already done this. We've just been looking at that y as a 0 so we can solve for it. Linear functions form a straight line and quadratics form a U-shaped known as parabola. So we're going to use this word bank to label. So this is a parabola. It's a U-shape, or it can go either direction. So this vertex, this is the vertex, and it is a max vertex. And the reason it's a max is because it's the highest point that graph is going. Versus this one, which is a vertex min, because it's as low as it can go. Okay, it's the minimum that graph is going to go. Nothing's going to go below that point. Nothing's going to go above that point. Axis of symmetry is the line that goes through our vertex, but you can see that it has the same amount of space coming from that point on each side. So this is our axis of symmetry. You'll notice there are two x-intercepts because there's two spots it crosses the x-axis. This is not always true. There is a situation where it only does one, and there's a situation where it does none. Intercept, sorry, I was not spelling that right. And then we have our y-intercept where it crosses our y-axis. The vertex is a minimum, so I'll have the min, when a is greater than 0. So when a is positive. So when that coefficient, that lead coefficient is positive, it's going to be a maximum when a is less than 0. So when a is negative. Now we've talked about this before, but we have what's called a parent function. And a parent function for a linear, because we've looked at that, is y equals x. It is the most basic, it's the most fundamental, it is the most simplistic version of that graph. Well, for quadratic, our quadratic parent function is y equals x squared. So we're going to start with looking at that graph. So I'm going to pick some x values. You always want to pick some negative and positive. Actually, we're going to do -3, -2. I like to have a nice symmetrical, meaning I like to have the same amount of negatives as I do positives because I feel like it gives me a good view of the whole graph. So I'm going to plug this in. -3 squared is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Now you can see that it makes a nice symmetrical pattern for us this time. So I'm going to go ahead and graph that. And all honesty, I'm horrible at drawing these. I'm good at drawing linear. I'm good at drawing circles. I'm good at a lot of other stuff, but I am not good at drawing quadratics. I'm not real sure what it is. I'm going to connect those. Ooh, that one actually looks pretty good. I'll give you a minute to get that down. All right, so let's look at this. Our vertex. So obviously, my graph is opening upwards. That's what it calls one of the openings at the top. Opening upwards, so I'm going to have a minimum. So I'm going to write that this is a minimum vertex. And it's at 0, 0. All right. That's, so when I have the quadratic parent function and it's just normal, like as simplistic as possible, it's going to have a vertex of 0, 0. Our x-intercept is also 0, 0. This is the case, one of the cases, of where my x-intercept is just 1 point instead of 2 points. My y-intercept is also 0, 0. Cross my x-axis at 0, cross my y-axis at 0. My axis of symmetry is going to be right here. It's going to be the y-axis. I can see that really nice. I'm going to get a highlighter. You don't have to do this, but I think it's visually easy to see. This is 1 away, 1 away, 2 away, 2 away, 3 away, 3 away. So that line, and I can't just put that it's the y-axis, I'm going to put it as an equation, is x equals 0. Our domain, even though we only see this part of the graph, if I keep going, I'm going to eventually go over to another x and another x. So all x's can be used on this graph. Y's is a different story. I can't have a y down here. It's definitely only going this direction. So my y is going to be greater than, sorry, or equal to 0. Alright, because it can equal 0, but my y's are definitely going to be only going up from there. Alright, let's look at another example. Okay, so now we have a different graph. This is not a parent function. They graphed it for us. And we can see that our vertex is down here. We can see that this graph is opening up. Okay, so my vertex is this point right there. And that point is -1, -9. Is it a min or max? It's a min because it is the bottom of the graph. Axis of symmetry. Axis of symmetry is going to go through that. I don't know if green is showing up on this video. I'm going to have to go back and... That's my... Oh, it did. Should have better in the video than it did on my paper. That is my axis of symmetry, and I can see that that is x equals -1. Our y-intercept, where is it crossing the y-axis? Here's my y-axis. It crossed at -8. So I'm put it as a coordinate, sorry. I can see I have two x-intercepts. Crosses at two different spots. It crosses here, crosses here. So both of those points we have -4, 0, and 2, 0. Domain, can any x value? Yes, this is continuing to go up and opening, so my domain is going to be all real numbers. My range, on the other hand, I'm not going to be going down here. I'm not going to be going down here because my graph is going up. So I know that my y has to be greater than or equal to this point, which is -9. For what values of x does f of x, so y, equal -5? So I'm going to come here and we'll see where y equals -5. Well, there is -5, my y equaling -5. What are my x values? Well, my x could be a -3. X also could be 1. Told you this lesson is very vocabulary based. All right, let's look at the last example. Our maximum points looks to be about right there. So that is 4, 125. My line of symmetry, I'm going to extend this out. It's easy to see that line of symmetry. The line of symmetry is going to be x equals 4. Y-intercept, where is it going to cross my y-axis? We decided in class it was about a 45. It's not exact, but x intercept. So one of them is really easy. So this one's really easy to see. I could see that that is 9, 0. But this one's a little bit harder. I mean, I could do a little guessing there. But remember, we have symmetry here. So this is 1, 2, 3, 4, 5 away. So this side has to be 5 away. Oh, I can't draw it going that way. So 1, 2, 3, 4. It's only going to go one spot. So my other one is negative 1, 0. That axis of symmetry tells me where this is going to actually cross. I don't have to guess. Domain, so looking at my x values, this is going to continue to get wider, so all my x values are possible. My range, on the other hand, I'm not going to be going above this, so my range is going to be y has to be less than or equal to that 125. Sorry, my phone is going off like crazy. Alright, so now let's look at last one. What is the best estimate of the largest value of x for which this function equals 80? So when my function equals 80. So here's my function equaling 80, which means y equals 80. And I've got 2 points here that x can equal. So it's asking for which one is the largest. So I have 1, I have 7, but 7 is my largest. So x would equal 7. All right, if you look at the homework, this question was confusing people. The minimum value of the function is blank when x is blank. So here's my minimum. So what is the minimum value of my function? My y is blank when x is blank. So it's just asking for the x and y of that minimum. All right, so you have 1, 2, and then a third page. It looks like a lot, but it's really not. It's just because the graphs take up quite a bit of space. If you have any questions, as always, email me, text me, whatever you need to do to get them answered. Hopefully you heard this video. My mic is kind of off to the side and keeps falling over. But if you have any issues, just let me know. Have a good day.